Hello everyone. Kindly confirm I am audible or not so that we can start the session. Yeah, hi everyone. Hi Princess. Hello. Audible loud and clear. That's great. Okay. So shall we start now? Okay, so let me share my screen. Even today, I come up with some of the agenda as well. I have prepared the roster, 1 month roster, so that I can complete this project as soon as possible, guys. Okay, and then we can start working on the another project, whatever the agenda that I have for this month, for my month. Okay, I already have prepared Excel sheet, all those roster I have already. Okay, so let me share my screen and then I will show you like what all those things I'm going to cover in this month. Okay, so I hope my screen is visible to you, everyone. So as you can see here, this is the whole roster. This is the whole agenda that I have prepared by date wise. As you can see here, the date wise agenda that I have prepared. 12th May, today is a 12th May, right? So today we are going to cover this topic, handling categorical data and model building. After that, logging, as I mentioned in the first class, logging database part, this is the very important. Okay, whenever we are doing end-to-end project. So let's say if our project is not working sometime, and if sometime is throwing the error, so how we got to know, okay, in which line, in which steps we are getting the error. That's why we are using a logging. Okay, so that whenever we are using a logging, we can got to know, okay, in this line, in this particular file, line number 20, line number 30, line number 40, we have a error. Okay, so that's why logging we will cover on 14th of May. 16th May, I'm going to cover a database because many of you have requested to cover a MongoDB and Cassandra, because nowadays like industry mainly using a MongoDB, Cassandra and SQL. Okay, so I will try to cover a SQL as well, but as of now, right now I have written here MongoDB and Cassandra. Next 18th of May, I'm planning to start first project discussion, whatever I have made. Okay, first, like this is the discussion part 1, and the next day discussion part 2, and within a 2 days I can finish all project explanation part. Okay, 1 second guys, I have some battery low, let me plug. Yes everyone. Okay, so this is the agenda that we have 18th and 19th May. We can finish this project. Okay, and after that we can start another project. Every day I'm planning to cover one project. 21st May, end-to-end project, one project discussion we can do. After that, YouTube live for the data science discussion. And then from 24th of May, I'm going to start another topic. If you want some other topic, because I started the recommendation system discussion. Second day, recommendation system algo discussion part 2, and then project discussion. within a 3 and 4 days. Okay, so this is the plan that I have for the month. After that, regular videos, whatever I'm going to cover, statistics I'm planning to cover, and then coding practice for DSA. Okay, so this is the plan that I have for this month. AutoML next. Yeah, I'm planning. Okay, so yeah, build start AutoML here. Else recommendation system. Based on your suggestion, I can take up projects and then I can start. Okay. Sir, can we submit this project to get an internship certificate? Yeah, but it's better you can do the some modification, because the same project, if you submit, then definitely anyone team got to know, okay, like where you have copy and paste the same code. Okay. So the Flask, Django, Python web application with the database is good idea for the project for placement. Yeah, definitely you can make a Flask and Django. It will be better you can make in a Django. Okay. Okay, now so let's start the main discussion, guys. So today we have a topic, handling categorical data and modeling, data modeling. Okay, so in the previous classes we have already learned how to handle a missing value and all. Okay, so let's start with the handling a categorical data. First of all, let's try to understand what is categorical data. So in our column, in our data, we have a lots of columns like review score, order status, payment, payment type, payment installments, payment value, and all those things, whatever the columns that we have. But as you can see here, the payment order status, it means our order is delivered or not. Let me write it down here. Our order is delivered or second is not. So this is the categorical data that we have. So let's take another example. City. Let's say we have some data, city columns. In a city, we have a different city like Delhi, Mumbai, Ahmedabad, Bangalore. So these are the categorical data that we have. Another examples like degree, highest degree. So under the highest degree, again we have a categorical data like high school, diploma, bachelor, master, PhD. So these are the categorical data that we have. But our machine learning algorithms only understand the numerical data, numerical values. So first, what we can do, first of all, we can convert this categorical data into a numerical form, and then we can apply a machine learning algorithm. Whatever the machine learning algorithm you can apply after handling a categorical data, then you can apply any machine learning algorithm. Whatever the machine learning algorithm suitable for your project, you can apply it. So as you can see, I have written the encoding techniques. We have a different encoding techniques. Start with the label encoding or ordinal encoding, one-hot encoding, dummy encoding, effect encoding, binary encoding, Bayesian encoding, hash encoding, and target encoding. These are the encoding technique that we have based on our data, based on our categorical columns. We can apply different encoding technique, and then we can apply any machine learning algorithm after handling a categorical data. So let's first of all try to understand label encoding or ordinal encoding. So data encoding technique, when the categorical data or categorical feature is ordinal, in this case retaining order is very important. So here we have a label encoding. So in a label encoding, what we can do, we can convert our all those categorical data. Let's say we have a 4 to 5, like we have high school. Second, we have, okay, my pen is not working. BTech. Third, we have MTech, then PhD. So what we can do under this label encoding and ordinal encoding, we can convert all those value. This is the highest degree that we have. So here we can assign highest value. So 4. After that, MTech 3. Then here we can assign 2, 1. Okay. So in this form, we can assign a data. We can assign an integer value if we have these types of education columns in our data. Okay. Let me take if anyone have any query. No. Okay, fine. So whatever the categorical data that we have, based on this, we can apply a different encoding technique. So under this label encoding and ordinal encoding, what we can do, we can assign integer value. Okay, like high school, master, BTech, MTech, PhD. If we have a 4 to 5 data, so we can assign high school as a 0 because this is the lowest degree that we have. Then BTech we can assign 1, MTech 2, PhD 3. Like this, we can assign a data whatever the data that we have. Okay. Now the next that we have the one hot encoding. What is one hot encoding? We can use this categorical data encoding technique when the features are nominal. Nominal it means do not have any order. Nominal it means in our data we do not have any order. Okay, in one hot encoding for each level of the categorical feature we can create a new variable. Okay, new variable it means, let me tell you. Yeah, so here under the one hot encoding we are discussing here one hot encoding. So let's say we have some data like high school, like education column. I'm taking education column where we have a high school, BTech, MTech, next we have a PhD. This 4 data that we have, and in this data if we want to apply one hot encoding, then what we can do, we can first take a data in this format. Right, it's not working. Yeah, first that we have here high school, then BTech, MTech and PhD that we have. Here if we assign 1, let's say if the data that we have is a high school, it means first is 1 and all the rest are 0. Second, if the person have degree of BTech, it means here we can assign 1, rest all are 0. So on, if the person have MTech degree, then we can assign only 1 here, rest all are 0. Same for PhD. If the people have PhD degree, 1, rest all are 0. Okay, so in this format our one hot encoding technique is work. Okay everyone, suppose we have this data set, okay, like high school, BTech, MTech and PhD. Okay, so let's say we have this data set. So here what we can do, here first if the people have high school degree, then we can assign 1 and rest all are 0. If the people have BTech degree, we can assign BTech degree person is 1, rest all are 0. Okay, so in this format our one hot encoding technique is work. Okay, now the third one that we have is a dummy encoding. So what is dummy encoding? Dummy encoding is a similar, we can say this is a similar to one hot encoding. Okay, like let me take one example. We have our one columns. We have our one columns like columns, and the second data that we have a code, pin code. You can say the data that we have here, columns A, columns B that we have, and the column C that we have. Here the code that we have the 100, second code that we have 010, and third code that we have 001. This is the one hot encoding technique that we have. One hot encoding, 1, as you can see, 100, 010. It means first people have a BTech degree, second people have a some different degree. Again, if the people have MTech degree and the rest all are 0, again the people have PhD degree, it means the all others are rest all are 0. So this is the one hot encoding technique that we have. One hot encoding. Now let's say if I want to convert, let's say if I want to convert this technique to dummy encoding, then what I can write here? Here I'm going to convert this one-hot encoding technique to dummy encoding. So the first one that we have, the one, if I know the first person have high school degree, okay, it means the rest all are 0. And if I'm assigning 100 here, like not, it's not 100, it's a 100, third value, third, like 3 data that we have, high school, BTech and MTech. If I'm assigning the 1, it means the people have highest degree. Then why I'm going to assign the rest all? We can remove this one. Okay, so let's say I'm going to remove this one. It means we have a 1 0. Okay, the people have highest degree and the rest all are 0. Again, if I know the people have MTech degree, it means the rest all are 0 that we have. If I'm assigning the 1, it means I got to know, okay, the MTech degree that we have, this person, and the rest all are 0. So no need to assign the more than 1 0, more than 1 value. Okay, because we all know like these people have MTech degree. Okay, again for this one here, if I'm assigning like 0 0, it means the third person that we have, because here we have only 3 person, A, B and C, only 3 person that we have. So if I know, okay, A and B did not have a like a PhD degree, it means C person have a PhD degree. If A and B person did not have a PhD degree, it means definitely the C person have a PhD degree, because we have only 3 person here. We have only 3 person only. Okay, I hope it's clear to everyone, guys. Yes, no, please confirm. Any doubt till here? Anyone? No. Okay, fine. So now the next one that we have, even if you want, then like not in this class, but next class I will take only for like how to handle encoding technique with a practical implementation. We'll create a one Jupyter notebook and then I will explain you each and everything. Okay. Again, next one that we have, the effective encoding, binary encoding, Bayesian encoding, hash encoding, and target encoding. These are the different techniques that we have to handle a categorical data. But mainly as like data scientists, many people are using label encoding, ordinal encoding, one-hot encoding, and dummy encoding. Rare case people know target encoding, hash encoding, binary encoding, and effect encoding. Even during the interview, most of the interviewer ask these types of questions. Like why mainly you are using the label encoding, ordinal encoding, one-hot encoding, and dummy encoding. Okay, because mainly people are focusing on this part, not like below one, like that I have written here: target encoding, hash encoding, Bayesian encoding, and binary encoding. Okay, now let's proceed next for our practical implementation. So now I'm going to use a label encoding here. Label encoding, it means whatever the data that we have. So as you can see here, we have a total 14 columns. 14 columns that we have: delivered status, delivered or not delivered, payment type, card. Okay, even you can check the unique data as well. Payment installation, no, customer city, product category name, seller city, seller state. So these are the categorical data that we have in our data set. So anyhow, first of all, we can handle this categorical data, and based on this, we can proceed next. We can use any machine learning algorithms, right? So here, this is the all column that we have. Okay. Now what I'm doing, I'm just importing the label encoding from sklearn. So you can just write from sklearn.preprocessing import label encoding, and after that I'm just using a label encoding. Let me open the label encoding documentation, label encoder documentation, so that I will show you in the better manner. See, whenever you are learning something, it's better you can go through the documentation first. Okay, so as you can see, we have some parameters. You can import direct pre-processing, and using the pre-processing, you can use this one. Here you can see we have some under the fit, we have a fit label encoder, fit transform, get params, inverse transform, set params, and transform. This discuss later these things, like what is the meaning of all those things. Even you can go through the documentation. It's a beautiful documentation that have written by the skitlearn. So you can go through this documentation and try to understand each and everything. Okay. Now come to our main point here. So I'm going to convert whatever the categorical data that we have, like customer city data, seller city, order status, categorical name, state, payment type, and product. These are the categorical data that we have in our data set. Okay, so I'm just assigning the label encoder, and then let me run this cell. And after that, as you can see here, we have from after assigning a data, what you can do, you can fit and then transform your data. Okay, so same thing I'm doing here. I'm taking the data. Under the data, I'm going to apply encoding technique on our status column. This is the first status column that we have. Fit, transform, and then same columns, whatever the columns we are going to apply. Same for product category name, city, customer city, seller city, payment type, customer state, seller state, and product category name. Okay, so I'm going to apply a categorical data. I'm going to convert this data, categorical data, into a numerical form so that our machine learning algorithms understand each and everything in a better manner. Because mainly, like not a mainly, our machine learning algorithms only understand the numerical data, not a categorical data. That's why whenever we want to apply any machine learning model, first of all, we can convert our categorical data into the numerical form, and then we can apply any machine learning algorithm. Okay, so here I'm using the label encoding. You can use a different encoding technique based on your understanding. You can do the trial and error method. It will affect on your model accuracy. Okay, after that, I'm just going to dump our data. Final L1. I already saved our data here. So let me show you. As you can see, I have this folder data, and under this data folder, I have a final L1, final 1 CSV file. I already dumped after converting encoding data into the numerical form. So let me run this cell. Let me read this cell, and let's take one cell here again so that we'll show you our data. df.head, and as you can see in the previous cell, here we have a review score. It's in the form of numeric. Order status, it's in the form of categorical data, but after applying a label encoding technique, it's changed. Order status, payment sequential, payment type, payment installments, all our categorical data is converted in the form of numerical data. Okay, after that, let me check the order status. So here, as you can see, here we have a order status, because as I already explained, label encoding, it means it's convert the data in the form of numeric, where you can assign a data like 0, 1, 2, 3, 4, 5 in this format. Like if we have a high school, and if I want to apply here a label encoding, it means I can assign high school as a 0, BTech degree as a 1, MTech degree as a 2, PhD degree as a 3. Right. So here you can see the order status. Whenever we are checking the unique value, it's already changed in the form of numeric data. Again, for the payment type, unique 0, 1, 2, 3. Okay, payment sequential. Let me check this data here so that I will explain you in a better manner. Here, it's not DF, it's a data. Okay, so already changed. So I have to rerun this data. So let me check here payment type. So here you can see the payment type, card, debit card. If possible, people use that card, debit card, cash. Okay, different options. So that's why our payment type option is changed into the numeric format 0, 1, 2, 3 format. Payment sequential, these are the payment sequential. As you can see, the same number that we are getting here. 1, 2, 3, 4, because we have assigned randomly. So based on this randomly, our model takes random data, and then they have assigned automatically all those numbers, whatever the categorical data that we have. Then I'm going to drop this data. So let me run this cell. Now it's drop on name 0 because we did not want our name data. As you can see, this is the index that we have. Okay. So for the further execution, I did not want this one. Now let me rerun this cell. So here you can see I'm just defining mapping 1, 2, 3, 4, 5 and review data. Like if one have they assigned 1, 2, 3, 4, 5, and then I'm just using the mapping function. After that, I'm doing the train test split. I'm taking the review score as X and Y as this one. Whatever I'm just dropping here. Here you can see I'm using the drop function to drop the review score only, and whatever the data that we have left, as you can see here, the review score. So I'm just dropping this data and I'm storing this data in the form of Y, and whatever the data that we have left here, this data. So this data I'm storing under the X so that we can split our data in the form of X and Y. Okay. And after that, I'm just importing train test split using the model selection. Okay. Scale and model selection. X train, X test, Y train, Y test, taking the data 75 and 25 format, 75 for the training and 25 for the testing data. Random state, I am defining 5. Okay, X and Y, this is the X and Y data that we have. Okay, even let me run this cell. After that, I'm just checking the X train and Y train, X test and Y test data saved. So these are the data that we are using for the training purpose, and these are the data that we are using for the testing purpose. Okay, after that, standard scalar. So can anyone tell me what standard scalar can do? Why we are using a standard scalar? Why we are using a standard scalar here? Can anyone tell me why we are using a standard scalar? Meanwhile, if anyone have any query, you can just put it down in the chat, guys. Why we are using a standard scalar here? What is the meaning of using a standard scalar? See, Python's standard scalar. This is it comes under the scalar. So scalar standard, this is the function. Scalar library offers the standard scalar function to standardize our data in the form of standard scalar, standard format. Okay, and this is the simple things I'm just telling you. Okay, to normalize data in the form of standard, we can say the standard format, right? Yes, normalize our data, same scale. Yes, X and Y data in the same scales. Okay, got it. Fine. Now here you can see I'm just defining the standard scalar. After that, fit transform on our X data. So even you can check it out the documentation as well. Standard scalar. Documentation scalar. Yeah. So here you can see standard scalar. If you define the parameters, attributes, you can define it. Should be up to you. Okay, everyone. Now I'm just transforming the data. Fit transform X chain, and I'm just transforming X data. So let me run this cell. After that, we can use the random forest classifier. Why the random forest classifier, guys? Why I am using the random forest classifier? I want an exact answer. Can anyone tell me why we are using a random forest classifier here? See, the random forest, this is the supervised machine learning algorithm that we have. It is used, like we are using a binary in the classification as well as regression problem. Okay. So random forest, it builds the decision tree on a different samples and takes their majority votes for the classification and average in case of regression. Majority votes is checks in a classification, and average in the case of regression. Okay, and one more thing, one of the most important features of the random forest, it can handle the data containing the continuous variable in regression and categorical variable in case of classification. So just remember, continuous value it can handle in a regression, and categorical variable it's handled in the form of classification. Let me return down here so that you can remember. Continuous data or continuous variable in the form of regression and categorical variable in the form of classification. Sometimes you will get an exact question during the interview as well. Most of the important features, mostly like interviewer ask like just tell me the most of the important features in the random forest. So you can simply explain, okay, continuous variable in like if the data random forest data can handle the continuous variable in the form of regression and categorical variable in the form of classification. Okay, so sometimes you will get an exact question during the interview as well. Okay, now let me open the documentation first, because in the documentation you will get better understanding. See, like whenever I am implementing any data science project, mainly I prefer documentation, because in a documentation you will get each and everything in a well and manner process. You can just go through the documentation, read out each and everything what they have written, and based on this you can implement any project. Whatever the project that you want to implement, you can implement it. Okay. Now, let me show you here. So, scale and ensemble random forest classifier. Whenever we are using the n estimation, n estimators, creations, max depth, mean sample, it means you want a better results. But right now here, I'm just showing you the simple one. I'm just importing the random classifier. If you want to do the trial and error, but I will tell you, whenever you are using this, whatever the parameters that we have under the random forest classification, right now after implementing this project, most probably as you can see here, I'm getting 81% accuracy. But whenever you are using these parameters, you will get better accuracy, 85, you can reach till 90. If your data is well and good, if you are defining all those estimators, all those parameters in a proper format, you will get a better accuracy and better results. Okay, so that's why I prefer to read a documentation mainly. Okay, so right now I will show you the simple one, but for your work, you can just go through it, do the trial and error, get a better accuracy. Even in the previous session, I already told, as your assignment, I already given, make sure whenever you come up with the next class, you will get more than 80% accuracy, not below 80. Okay, so I'm just importing here the random forest classifier algorithms, because whenever we have a continuous variable, it will work on the regression data, and for the categorical variable, it's work on the classification data. Okay, so I'm just importing the random forest classifier, defining the model, and then I'm just define the fit. As you can see here, somewhere here you will get. First, import the random forest algorithm, define the data, fit, train, and net. Let's define this one, guys. Only two things under this one. Max depth 2 I'm defining, and random state, as you can see here, 0. So what is max depth here? Let me read this documentation here. Max depth, somewhere here you will get. So max depth of tree, if none, then nodes are expanded until all the leaves are pure, until all leaves contains less than minimum sample split. Okay, let me rerun this step and then I will show you the accuracy first. %74% accuracy. Now it decreases. Let's remove this one. So here you can do the trial and error, then you will get a better accuracy and better model you will get. It's rerunning because we have a huge data, so definitely it will take some time. As you can see, again I'm getting whenever I'm like removing this one, but let's take some data from here as well. As you can see, base estimator, the child estimator template used to create the collections of filtered sub-estimator. So you can read this documentation. It's a beautiful documentation that we have. So let me take up some of the things from here. Max Dev, this one I have to take. And again, I'm going to take this one. Let me define the max days, this time the 5, not. I want to define like stretch our tree in 5 days. So that's why I'm defining 5. And now let's run the model here. Again, getting the 75, little bit better, because previous one we are getting the 74 something accuracy. Okay, now let's remove this one again so that we can proceed next. Now let me run. Now 81% accuracy. So here I'm using the random forest classifier. You can use a different machine learning model, do the hyperparameter tuning, get a better accuracy. Okay, so this is the task that I'm going to provide you guys. First, use different machine learning model second, to get a better accuracy, to get a better results. Second, do hyperparameter tuning. Okay, to get a better results. Okay, so you can use 2 things. First, use a different machine learning model. Second, do the hyperparameter tuning. Based on this, you will get a better accuracy. Right now, we are getting here 81% accuracy, but after doing the hyperparameter tuning, definitely we will reach more than 85. Okay, so this is the task that I'm going to provide you guys. Just try to follow and try to complete this task before tomorrow. Tomorrow 5 p.m. Okay, now let me write here in the bold format task so that you guys can remember. Okay, task. Okay, now model prediction, the next step that we have. After that, I'm going to check the confusion matrix. So can anyone explain the confusion matrix? Why we are going to check here the confusion matrix? Anyone? And why we are using the confusion matrix? See, the confusion matrix we are using to check the performance of our model in a classification problem. In a regression, we have a different things. We have accuracy, we have a MSC, we have a RMSC. Okay. In a regression, not a classification. In a classification, we have a confusion matrix. Whenever we have a classification problem, we are using a confusion matrix to check the accuracy of our model. Okay, true positive, true negative, false positive, false negative. Okay, so here I'm just importing the confusion matrix and classification report, where let me show you the documentation again so that you will get a better understanding. Sklearn. Yeah, mainly I prefer the reader documentation. Okay, so here as you can see, we can import X, Y, X training and Y prediction. So same thing that I have defined here, X text, and Y prediction here. Okay. Then whatever the data that you have under the Y test and under the Y prediction, you can define. After that, if you want to check the output, you can define Y test, Y prediction, and label whatever the label data that you have. As you can see here, label data that we have 3 and word and cat. So 3 data that we have. Based on this, you can define it here. Okay. So same thing that we have done it here. Confusion matrix. First, I'm just printing. Under the confusion matrix, I'm just taking the first one, 0, 1, 1, 1, 0, 1, and 1, 0. This is a different format that we have. First, 0, 0, 1, 1, 0, 1, and 1, 0. 0, 0 for true positive, 1, 1 for true negative, 0, 1 for false positive, and 1, 0 for false negative. And here you can see the output that we are getting here. True positive 881, true negative 232, false positive 11, false negative 33. Okay. Yes, Raghav, if I'm going to explain each and everything in detail, it will take 1 hour of time. For explanation of only this one, performance matrix. This is the performance matrix that we have. And if I'm going to explain this thing, it will take 1 hour of time. Okay. So if you guys want, I will take another session for this one, for categorical handling and categorical data handling, like checking accuracy or a performance matrix in a classification as well as a regression. I will take a one session and then I will explain each and everything. But if I'm explaining here, it will take 1 more hour. Okay. We'll take it in future classes, not now. Okay. Right now, just try to understand this one. Okay. So here we have a true positive 881, true negative 232, false positive 11, false negative 33. So till now, anyone have any questions? Any questions you want to ask? Yeah, let me check it out on YouTube comment as well. Anyone, any questions? Till here? Yes, no? No questions, right? Okay, fine. So now let's proceed next, guys. After that, we got the data. We have this accuracy. This is the confusion matrix that we are getting, the performance matrix. Okay. So what's the next step? After getting the accuracy, if you want to use a hyperparameter tuning, do it well and good. Else, we can save a model, and the same model we can use in a production. No, sir, I have to practice. Yeah, definitely do the practice so that you will get a hands-on experience as well. Okay, just try to complete this one as well as a challenge. Just try to take it. Okay, so that you will get a more confident. Now we are going to save our model. So I'm going to save this model as a final model dot pickle. Okay, I'm just dumping our data. Again, I'm just opening our same data here, standard scalar, order status, because we have a different data, right? So I'm just saving our model, all the model, whatever the data that we have, final model, standard scalar model, order status, payment, status pickle. And after that, I'm just going to open all the data one by one. Standard scalar data, model data, state data, categorical name, city, and service city. So these are the data I'm going to open. Categorical name, I'm going to just transform this data. We are getting this one. Then SP, I'm just taking the random data from our columns, whatever the columns that we have here, as you can see here. So from customer state, I'm just taking the SP here. So as you can see here, we have a somewhere here. State SP I'm taking. From the city, I'm just taking this one. We are getting this output. From here, I'm just taking this one. For the prediction wise, I'm just defining here standard scalar transform, whatever the columns that we have. Whatever the columns that we have, total we have a 13 columns. As you can see here, total we have a 13 columns. All the 13 columns that we have here, somewhere here I have printed 14, but after splitting train and test X and Y, we are getting 13. Okay, as you can see here, somewhere here I have written here 13. Okay, so same I am defining here random data to, let me rate top 10 head. So from order status I'm taking 2, payment sequential I'm taking 4, payment type 2, installment 5, payment value random data again I'm taking, customer city this one, customer state 25th, price this one, freight value this one. So I'm just taking the random data so that we will get the output. And after that, I'm just scaling. Standard scalar is not defined. So somewhere here I have defined, but again I'm getting the error. Standard scalar. Okay. So let me copy the code from here so that we can import. Yeah, I already defined, but these things, but no issue. Here, as you can see, somewhere here I already defined standard scalar. Yeah, this one. So let me rerun and then no standard scalar. I have to write some this one, right? Okay, so right now let me run. Okay, pickle is not defined, so let me take import pickle. Now let me run. Now it will work. It's only importing here, so definitely it will work. Yeah, it worked. Now let's rerun all the cell, whatever the cell that we have, and now it worked. So after that, I scaled the data, whatever the data that I have here, predict, scaled, and I'm taking the first one. So the first prediction that we are getting here is 5. Let's take the same data 2 that we are getting the first. In the payment sequential, I'm taking the 1 data. Let me copy this cell. And then in the next cell, I'm going to define here. First 2, this one. Payment sequential, I'm getting the 1. Payment type, again 1. Payment installment, 8. Payment value, same exact data I'm going to put here. Payment city, this one. Customer, correct. Price, 185.0. Value, this one. Product category name, 32. Correct. Quantity, 1.0. Next, seller city, 503. And the last one, 25th. Let me rerun this cell. Now, this one. And that prediction that we are getting the 5. Let me, okay, not this one. Let me write this one here, 1. Run this one because I rerun this cell again. And then this one. 5 we are getting. Let me add some different value here. 32461. Let's change some value here again. 32, 46, and then let me run. Okay, so right now we are getting the same data, but let me 100 point something. Let's change this one as well for 500, and this one for 18. I hope we'll get some other output now. Okay, so as you can see, we are getting the same output. So what is the meaning of this one, guys? Can anyone tell me? We are getting the same output again and again. It means definitely our model is not working well or something else, or we have some overfitting in our data. Even we are getting the 81% accuracy. Yeah, so yeah, little bit our model is overfit. So yeah, you can do the hyperparameter tuning, use a different machine learning model, and get a better accuracy and get better performance in your model. Okay. Yes, guys. Any questions? Anyone? Yes, no? Okay, so this is the agenda we have to finish today. Handling a categorical data into a numerical format so that our machine learning model will work. Second, we have performed here only random forest classifier model, machine learning model. What you can do, you can apply a different machine learning algorithm, do the hyperparameter tuning, and come up with better accuracy. Okay, everyone. Now let's come to our roster part again. So this point that we have finished. Next class that we have on 14th on Saturday. Most probably I will take on like 6 p.m. or 7 p.m. You will get an update. Don't worry. In a community section, you will get an update. So next class, this is the very important next two class that we have, logging and MongoDB database. Okay. So make sure you can attend this session, share with your friends so that they can also attend. It will help you for long-term, guys, logging part and MongoDB, like a database part. Okay, because whenever we are doing any types of project, I'm not talking about the like a machine learning or data science, any types, any Python development projects, definitely you can use a logging and MongoDB. It's required, it's compulsory. Because let's say whenever sometime our work is not working, our project is not working, sometimes we are getting error, then how we got to know without using a database and without using a logging, okay, in which line number, in which files we are getting the error. So this is the important concept that we have, logging and MongoDB, like logging and database. I'm not talking about the like MongoDB and Cassandra. Logging and database, we have a very important concept for any types of projects. Going forward, this is the plan that we have. Final project discussion. We'll take 2 classes for the project discussion, and after that I'm planning to take 1 project discussion in the one single class so that you got to know, because we have already learned all those concepts. And after that I'm planning to take in alternate age all those feature engineering techniques, handling a categorical data, handling a missing value. We have a different techniques. Okay. And apart from this, if anyone wants any video on any particular topic, you can write it down in the chat, guys. And let me download this notebook and will provide you right now so that for the practice purpose, you can use this notebook. So let me upload on my drive. Let me edit this file so that you cannot confuse day 1 to day 4, day 1 to day 4. Yes, so let me put it down in the chat so that you can go through it and then you can use it. Yes, guys. So I just pinned this message. So you can just check it out in the chat and then you can go through it. No questions? Yeah, it's a 1 hour classes because we have finished all like model building or like a categorical data, handling a categorical data. So yeah, if anyone have any query, you can just put it down in the chat, or YouTube people, you can just put it down on the like you to comment. Okay. Okay, fine, guys. So no questions that you have. So now let's conclude this session and let's see on 14th of May in logging classes. Make sure you can attend this class, guys. Don't forget to attend this class. Okay, because this is a very important concept that we have under the logging and under the Mongo, like database. So make sure you can attend this session. Okay. Yeah, okay, guys. So that's all about the today's session. Let's see you in the next class on 14th of May. Okay, where we can discuss a logging. Okay. Yeah. Bye, everyone.